Tonight is August the 2nd, 2018. I'm going to wrap up an amplifier I built several months ago and have been listening to it daily ever since I posted the first video about it. Actually, I don't remember how long ago that was, but it's been several months. This is a beautiful sounded amplifier. It runs a quad of 300 Bs. These are the electro harmonics. They're just absolutely beautiful. I can't say enough good about it. I've really enjoyed it, but it's time that I believe I start packing it up and sending it to the rightful owner. What it was built from was the schematic of a Brooks 12A. Let me show you that Brooks 12A schematic here. I'll have to kind of manually do the camera here. Here's the schematic of it. It's been redrawn by a good gentleman and posted. Brooks 12A. You have to study this thing for a while. Now, this one uses a pair of 2A3s, so the output stage is from a different amplifier, but all this part back here is built exactly like this. This is not a test bench amplifier where I am endlessly trying to make it better and better. That's just not the purpose here. The purpose is to build it exactly like this, and it is built exactly like this, component for component, with the exception of the feedback, which is right here. I had to work with that because I have a different transformer and I'm using 4 300 Bs. But this part back here is the same. Well, it is the same, but I'm not using a 6J5 either. I'm using a 7N7. I'm not using a 6SN7. I'm using a 7N7. The 7N7 has the same specs as the 6SN7. 6SN7 is a dual triode, as we know. The 7N7, and I'll show you that to you here in just a minute, is a dual triode, which is a 6SN7, but it's in a loctal base, and it has a different pinout. Now, 6J5 is half of a 6SN7, just like a 6C4 is half of a 12AU7. I think everybody knows this. So the part that makes it the same is these values of components in here, and especially this this driver transformer right here. The beauty of using a transformer like this, not a transformer but a tapped choke, is that you can get basically twice as much drive to drive the grids of these tubes, like a 2A3 or a 6B4 or the 300B. And the reason that you need more voltage, you don't need more power, you need more voltage. Because either running Class A, you're not drawing any grid current, so you're not loading the driver stage. So the idea is to provide it more voltage. Now, oftentimes this gets described as we need more power. You don't need more power, you need more voltage. And if you use these chokes in here, which are like 300 Henrys, then you'll get almost twice as much voltage as you do if you use a regular RC coupled circuit. And the reason you need this much higher driving voltage is because of the bias that's necessary to put on these tubes. And the reason that it's necessary to put a lot of bias on these tubes, like in the case of these 300 Bs over here, they run around minus 90 volts. And the reason that you've got to have all of that bias on it is because the gain of the tube is very, very low. The gain of a 6B, of a 300B is something like 3.5. It's just incredibly low, but it's also very, very linear, and that's why we like it, and it sounds really good. Nice and linear, takes a tremendous amount of bias voltage to control the current flowing from the cathode to the plate. If it was a zero bias type triode, then we wouldn't have to have any kind of bias on it. If it's like a 6V6, it takes like minus 15 volts. These are generally true and in the ballpark. About minus 15 volts for a 6V6, about minus 35 volts for a 6L6, about minus 50 to 55 volts for a 6550 KT88. But when you get to these old triodes over here, when it has a super low gain, and you have like minus 90 volts on the grid, then you've got to have a lot of voltage. You've got to have enough drive voltage from this stage right here, drive voltage, not power. You've got to have enough drive voltage to be able to drive the grid to the peak of close to the bias. If the bias is minus 90, you want a signal that has a peak voltage of close to 90 volts so that you can drive it close to zero, but you don't want to drive it all the way to zero, because then you'll start drawing grid current and everything goes to hell. But this type of loading circuit right here is very good for that, and that's why these types of circuits are used to drive these old tubes. Hope I made sense with all of that. Okay, now with all that said, it also has a gorgeous old UTC transformer here. This transformer right here is actually an input transformer. It's not being used right now. I have a switch here on the front right here that I can go from the high Z input to the line input and drive it directly. You don't get a lot of power out of it. It's got its own, I guess, clean and unique sound. This says it's ready, this is AC on, and this is the on-off switch and gain. Here are the 7N7s back here. Like I say, they're the equivalent to a 6SN7, except they have a different pinout, and they're a loctal base instead of an octal. And here is that 300 Henry choke. I think it's called a grid choke nowadays. What's underneath this are some tube sockets. When we started on this amplifier project, it wasn't known exactly how it was going to progress, so there's a lot of sockets under there that are not being used. They are wired for the filaments, so they can be lit up for just the effect. And I put some Velcro on there, this piece of aluminum, just to cover it up. Now here's the power supply. This is quite a serious power supply. Huge transformer. This is a 400 milliamp. This is a 800 volt, 400 milliamp. This is a big filament transformer, filter capacitors, choke. In this case, I'm using 866 rectifiers, and they are on. You can see how beautiful they are with their purple. Here's a hum balance. This one right here is actually just parallel to these guys right here. And this 115NO180 is a delay relay of 100. It's a 115 volt coil with a 180 second delay. And what that does is gives you 180 seconds for the filaments to warm up on these guys right here before you're applying voltage to it. I'm going to show you underneath it, but let's do some quick measurements, and I'll show you. Got to take this thing off the stand though. This camera. Okay, to keep the video from being too long, I've already got some things set up. I'm going to turn off this light right here, and I hope that everything will actually be better. Maybe. Okay, this is power output, and it's across 16 ohms. I built this on purpose to drive 16 ohms. Here's the output on the oscilloscope. Here's its THD, 0.8% at a kilohertz, right at 40 watts, which is just about all you can get out of these 300Bs, which is actually quite a bit of power, I think. If we want to look at the Spectra Plus and we hit run, that's what its harmonic profile looks like. And it says its THD is about 0.8. It agrees with the Tektronix equipment, about 0.8%. This one says same thing, at a kilohertz, at about 40 watts, and it's actually nice and clean. There's a lot of spurs in there, so this thing is really full of harmonic content. But I think there's just something about it that we like. I really can't quite describe it. I actually like triode amplifiers, and that's what I listen to. Here's a triode amplifier I listen to all the time. I'll turn the light on so you can see it. I've shown this one so many times. This is 6B4s. The 2A3 and the 6B4 is actually the same tube, except they improved the 2A3 and made it a 6-volt filament, and they put an octal base on it. These tubes are probably from the 1940s, and it does a good 15 watts. Just sounds great. Driving it with a pair of 6SN7s. Very similar to this Brooks 12A, but different in the sense of the input, in particular this part over here. By the way, I'm going to go ahead and close this, and I'll probably lose the page. You probably want to look these up. If you go out and Google 100 amplifiers, part 1, 2, 3, or 4, you will find all these books. I got every one of these online. I have a very nice high-end color printer that I liked them so much I printed all of them. They are absolutely gorgeous books. Full of schematics. I mean, this is the cat's meow, I'm telling you, for books. Okay, look at this one. 1916 to 1945. This is part 1. 100 amplifiers, part 1. Part 2, part 3, part 4. And then the years are different, of course. But all color photos. Just some really... These books are just beautiful. And they're absolutely free. Not the books are free, but the files are free. And it depends on whether you want to print them and spend the paper or not. So here's part 1, part 2, part 3 from 1955 to 59, and part 4 from 59 to 82. Love these guys. What I'm using for a dummy load here is a big old variable resistor. It is wire wound, but the inductance of it I've measured. I don't remember what it is, but it's very, very low, so I do not have an inductance problem. You can call this one, for all practical purposes, non-inductive. The word non-inductive is never actually quite accurate. Very low inductance is what it is. So I can set it to 16 ohms right there, just slide this thing down to there. I think it'll dissipate about 400 watts, so I don't have to worry about anything. Okay, let's see, what do I want to show you now? I want to show you its frequency response. It's actually rather contoured. Get all the glare out. You can see down at the low end, it is attenuated, but the high end is not. Back in the day when these designs were made, there was an attitude about limiting low frequency response. As you can see, right here I scanned from 30 hertz to 15 kilohertz at a reference level of 20.24 volts. If you square that and divide it by 16, you get about 25 watts. So this is running at 25 watts. It won't do as well at 40 watts at the low end as it does at 25. So depending on just how conservative you are, this is a about 100-pound 25-watt amplifier, but it's actually a very, very nice sounding amplifier. It's as good as anything that's ever come across my ears. I'm really pleased with it, but I thought I'd do the video and send it back. I don't think there's really much more to show about it unless I just get really tedious. I've been very busy into building an 833 amplifier with these big guys right here, but I had to take some time out to work with this one. Let me power it off and show you underneath it. So let me turn it off and turn the lights on and get set up, and I'll show you what I've done underneath these two chassis. Okay, underneath the amplifier chassis, here's the connecting cable. This connects to power supply, as you can see, into this connector right here. I can't push it on with one hand. There's the output, input. This is in case you want to, this is a 600 ohm input, just in case you want to drive it with this transformer right here directly driving the grids of the 300Bs with no amplification. No vacuum tube amplification, that is. You have voltage amplification in this transformer right here. And I suspect back in the day that as expensive as they are today, they were probably cheaper to make these transformers with voltage gain in them than it was to actually build vacuum tube stages. And then you switch it over right here. If you switch over to this connector right here called line, then it just goes, the only thing that's being used then are the 300Bs being driven by this beautiful old UTC transformer directly. Here is the circuit up there. That is faithful to the Brooks 12A. Like I say, all the way down to the feedback. I had to work with the feedback, and then instead of driving the 2A3s or driving the quad of 300Bs right here, right there. And these are the two 7N7s up here, and they're octal sockets, and then these are, loctal sockets, excuse me, and these are the octal sockets that are not being used, that are covered up. Here's the on-off switch and the volume gain control. This one says that it's powered on. This one says that it's ready. This one says that it's ready because this 115 180 over here has its time has expired and the contacts are closed and power supply is providing power. Okay, now here, this is a bias resistor right here. It is cathode biased. There's really not a whole lot in here to show. Here's that big transformer. I had to do some retrofitting, so I had to do some real cutting there, but I guess it turned out okay. These are filament transformers. There's the choke, the capacitors, and the high voltage wire for the 866As, which are actually wired parallel with that 5U4 too. So you really don't have to actually use these 866s. You can either use these or you can use this one, and in this case I've got them all parallel. They don't come online until this 115N0180 times out up here and turns them on. We also can use some 3B, oh darn, I don't remember, some of those xenon rectifiers, and they work in here too. They've got the same pin out, and you don't have to use the plate cap. Let me lay this thing down. We'll look at the top of it. Yeah, actually the other tubes that can be used is a 3B22. If you want to use the 3B22s in here, you just simply unplug the plate connections here like this and just leave those as they are, and pull these guys out, and you can plug in the 3B22s. I don't have them down here right now, and I'm not going to go crawling around in the attic at the moment, but they'll plug directly in there, and then you don't have to use these connections right here because they have the plate connections. It's all internal. Actually, each 3B22 is a full wave rectifier like a 5U4, but since we had two sockets, I put two of them in there and used the double plates, because we are drawing a lot of plate current. I believe that the idling plate current, some of this is coming back from just memory, but I believe the idling plate current is about 90 milliamps on each tube, on each 300B. So for them now, 360 milliamps. Maybe it's not quite that high, but it seems like it is. It's pretty high. This is a hum balance. It doesn't seem to make a whole lot of difference. It doesn't seem to be terribly important. There is an on-off switch on the back of it. I want to be real careful here. I'm going to be really irked if I knocked those things off at the floor. Nothing fancy here, just a basic power switch if you ever want to use it, because you're really going to be plugging this into a preamp most likely, and a fuse of course. And here's that that power connection that supplies all the power and filament voltage and whatever, on-off switch connection and everything over here to the amplifier. Let's set this guy back down. So there it is. There's a quad of 300 Bs that just sounds marvelous. I'm very pleased. I hope the owner is as pleased with it as I am. These vintage, gorgeous UTC transformers, just can't get over the beauty of those things. I do have all of the bottoms and all that kind of stuff. It's all up here. These are the things that go on the bottom. You know, got some other hardware, and then there's hardware down here. I've got these are the bottom plates for it, so it'll actually be complete when I put it together. But there it is. I don't see too many amplifiers where people have gone to the trouble to use 4 of these guys. Kind of expensive, especially these UTC transformers. I think are really top notch. Well, there it is. I hope you guys like this audio equipment, and enjoy this stuff. I try to build unique equipment, not just duplicate things that have been out there multiple times, and let's see how it goes. So there you go. Thanks for watching, and I'll see what I can come up with next.